Now let us look at the broad view of steps to do DH representation. Why do we require a broad view? Because actually DH representation is a series of procedures that we have to carry out. So it will take a lot of time to explain each one of them and to finally reach the end of how we calculate. So if we get a broader picture, we will understand how it is going to go. So basically there are three steps that we have to do. The first that we do is we assign a reference frame to each joint, and that is we start from the universal reference frame to all joints to the tip of the tool. To just give an example, I have drawn a robot here. As you can see, this robot is having many different joints. One joint is here, which generally we call it as a hip joint, so it's a base, and there is another revolute joint which is here. Then we are having another revolute joint which is here. Then there is a 90-degree link, and here we have a prismatic. So this is all a revolute joint. Okay, this is all revolute joint, and here we are having a prismatic joint, and then followed by a end effector E. What we have to do in the first step is we have to assign a three-dimensional. So let me do that. We will assign a three-dimensional. So first we'll have to do for the case of the universal reference. So let us imagine that this is going to be a universal reference frame, which is U, followed by the base frame, which is having another frame, followed by this one, which will have a different frame. So let me say that it's having a frame, some frame. Okay, now there are rules for making this frame. That is why I said that it will take some time, but we will see. So this is another frame, the third frame for this one. Now I am just simply drawing the frames like this, but there is a rule. Okay, now let's say that this one is going to have a frame, another frame which is the P frame. Let us say it is going to be like that, and finally the end effector will have its own reference frame. So we have to make a reference frame for each and every joints plus the universal reference frame based on which the whole movement is going to be there, and the end effector. And if you remember, we had very clearly said that we are always interested to find out what is the transformation matrix of E, the end effector, with respect to U. That is what we are basically always interested to find in each and every. Even in the last module or previous module, we had done the same thing. We had tried to find out what is the transformation matrix. So here also we are going to do that. So first we have to define the reference frame to each joint. Okay, the next step will be find the transformation matrix from first universal frame U to next frame, from, and similarly another transformation matrix from that frame to the next frame, and so on till the frame of the tool. So we have to find out the transformation matrix for, let me draw it. So between U and R, there will be a transformation matrix that relates R to U. Okay, let's say this is R1, this is R2, this is R3. And similarly, there will be a transformation matrix between these two. So it will be what relates TR2 to R1. Similarly, another transformation matrix that relates these two, R2 and R3. So I will say from 2 to 3. Okay, let me change this one because it's going to be it looks very complicated. So I will simplify it. I will say what is the transformation matrix between so again let me change it, so I will call it 1. Okay, so let me say, So what is the transformation between R1 and R2? That means how is 2 related to 1? How is how is 3 related to 2? I have written it wrong here. So how is 3 related to 2? How is 3 related to 2? Similarly here I will try to find out how is P related to 3, and here I will find out what is the transformation matrix that defines the relationship of how E is related to P. So for each and every combination of the frames, from one frame to another frame to another frame, we have to find out what is the transformation matrix. Okay, and that we already know, we have already done in the second module how to find out with the help of post multiplication, pre multiplication, that we will see. Next is the last step, which is multiplication of the all. So that will be, we combine all the transformation matrix we have found in the above step, that is step 2, and get the robot's total transformation matrix. It means that we will multiply, so we have started from here. So here it is, how is 1 related to U, and also, so we will multiply it in such a way that how is 1 related to U, and how is 2 related to 1 multiplied with, so it's all multiplication, matrix multiplication. How is 3 related to 2? How is P related to 3? And how is E related to P? So see, once we multiply like this, you always know that when we multiply here, it is 1 and 1 will cancel, 2 and 2 will cancel. So it goes like this: 1 and 1 will cancel, 2 and 2 will cancel, 3 and 3 will cancel, P and P will cancel, and we will finally get the relationship directly between E and U. And that cancelling, I am just saying that, symbolically it will cancel, but basically what is happening, the multiplication of these 5 transformation matrix will give me what is the final relationship between E and U.